think my real interest, if I traced it back, was curiosity about the physical world, which is what physics is.
One might imagine, at least, that one's talking about nature when one's talking about the character of physical laws. But I don't want to talk about nature, but rather how we stand relative to nature now. I want to tell you what we think we know, and what there is to guess, and how one goes about guessing.
This is the piece of the equation which describes how the Higgs field acquires its value.
Good evening, and thank you for inviting me to this online session of Physics Matter. My name is Sergio Bertolucci. I am a particle physicist working currently on neutrino physics in the US. And tonight I would like just to offer to you a few points of reflection about the digital transformation which is happening around us. As scientists, we have grown up. The older among us, like me, have followed all this development of computing, of ICT in general. We were essentially seeing the computing power go from the kiloflops to the teraflops during our lifetime. We have seen the emergence of the network, of the internet. We have seen the establishing of the web. We have seen and we have built also more and more instruments which were producing a lot of data and which now are becoming pervasive in all our life. So what we have seen constantly growing up and accelerating incredibly is this convergence of which is happening nowadays at an incredible pace of the Internet of Things, the number of devices which can produce directly on the internet data, measurements, information of any sort. The fact that we can get access to almost infinite computing power through the elastic cloud, where we can access to computing power without having the need just to build our own computing center, and the enormous amount of data which are available through more and more performing networks. This is complemented by the capability, which we generally call artificial intelligence, to develop software which can look at this data and almost in real time and get out information and knowledge. So essentially, the cycle of data, which goes from unstructured or less poorly structured data to appropriate combination of them just to extract their information, and then through the presentation of this information in readable way, and finally to the knowledge, is seen nowadays very important development, which are no longer internal to our field, and which poses us some very deep question, because this is really a transformation, a deep transformation which happens in our society, and which is keeping happening at a very fast pace, and which will inform the future of this society, and we are within it. So artificial intelligence, which is the way in which we are trying, which is spurred essentially by the fact that we are no longer capable to keep up after all the amount of data that we are generating, is not a new idea. of course, it has evolved in the course of the year considerably from the more primitive way in which we were trying just to have the computers behave like our like intelligence people, in the sense that doing some job, some assignment in a smart way, to later to the development, which was mainly started in the 80s, in which essentially we were starting investigating the capability to inject in a software, in a computer, the capability to learn without being explicitly programmed, to the latest development nowadays, which are generally called like deep learning, where essentially we try just to mimic the structure of our brain into the silicon. Now, if we would like just to make a sort of a sketchy representation of that, computing science, ICT in general, is the general framework which encompasses everything. And the subset is artificial intelligence. Machine learning in itself is a subset of a particular way in which you can address artificial intelligence. And neural network and deep learning are even a more specialized part of it. So just to give you a glance about it, I am not a specialist, I am a user of this, even in our field where we are starting using very much these capabilities because the amount of data we are producing sometimes defy our capability to get the information out in a reasonable time. And essentially you can divide the machine learning in three big categories. Supervised learning, in which you train appropriately your software, your machine, let's call it a machine, by essentially posing it what you think that it should recognize among a noisy type of data. And this, at the end, if you are good in doing this training, and if you have enough data just to feed in of different categories, will resolve your problem of classification and of regression. So it will be able just to produce an output which essentially predicts an outcome. There is another interesting part of machine learning, which is unsupervised learning, in which you design your software in such a way that it can recognize features from the data structure by itself. And then this is less predictable. You will not be able just to use the output, but it can signal out correlation and qualitative evaluation of a big amount of unstructured data in an interesting way. And then there are forms of reinforcement learning, in which essentially you treat your software like when you are training or trying just to teach your favorite pet just to do something. Is another approach to artificial intelligence in which you reinforce a positive outcome and in such a way that the program slowly learns how just to maximize its rewards. If you go a step further, you can essentially try to imagine, to mimic in silicon what your brain is doing. Our neurons are attached to other neurons by dendrites, axon, and they are embedded in a network, in a fantastic network in which the connection are extending very near and very far. And the combinatorial capability of this connection at the end give us the perception of reality and our capacity and our ability just to imagine something and take an action for something. You can try in a very crude way just to mimic that into the behavior of a computer, and essentially you connect inputs to some intermediate step in which you sum up with a weight the information you're getting from your input, and then after this sum exceeds a certain value, you have an activation function pretty much mimicking what our brain is doing. There is a novelty if you take this approach, that for the first time, the intermediate layer, the one which separates the input from the output, are hidden to you. The software, the machine writes its own software and is not showing it to you, because the more it progresses in this deep learning neural network, it cancels what it has done before and essentially carries over only the next step. And this is already a big difference. Now, let's see the difference between our type of perception. When we look at the picture of a cat, our neurons, our dendrites, are stimulated by input by the dendrites, and the connection of the axons connect in our brain through a very sophisticated way this image to the concept of a cat. For a computer, this is a set of numbers connected to to each pixels in which this image is passed to it. And after some training, a good program will tell you that this is 82% probability just to be a cat, 15% just to be a dog, 2% to be a hat, and 1% just to be a mug. Now, this is a pretty impressive thing if you can do that like that. But what is happening nowadays is that sometimes computer programs are then responsible for actions. And in this case, this result would be not good enough, because in your futuristic smart home, where you have a futuristic coffee machine, if the coffee machine decides in 1% of the cases just to pour the hot coffee on the cat will not be happy. So essentially, all these procedures are very good, very impressive, and at the same time are posing us some question if we are using them not only just to predict or to orient or just to find information, but also to act. And this is a very simple example, but is what, for instance, we are trying just to do since a few years with self-driven cars. I will not mention military, because this is another thing where automatic and very fast reaction are being explored, probably in some ethical corner, which is not very close to our job. And not only that, because sometimes correlation can be funny or biased or have no sense. This is, for instance, the correlation between the money spent on pets in the US and the number of lawyers in California. The correlation coefficient in this way, in this example, is 100%. Although it's difficult, at least for me, just to recognize that these two information might depend one from the other. Now, what is in front of us now is, as a matter of fact, that we are in front of something which is very different. It took us millions of years just to evolve our brain. to go from the trees to a semi-erect posture to almost erect posture, because we are always looking at our cellular phone. And these last steps are happening not in under the years or thousands of years, are happening very fast, in which we are becoming more and more entities which have some connection with something which is that we perceive not to be natural. And I mean, natural, non-natural is a matter of metaphysical definition. And I would like just to bring you back to this reflection later on. I would like also just to show you this famous curve which describes emerging technologies. They go essentially from their inception, they go very fast to a peak, and usually is called the peak of inflated expectation. And then they, some of them fall down in a sort of deep of the trough of disillusion. And then some of them succeed just to reemerge through this enlightenment curve, and they are becoming commodities that we can use. Now, this curve, which is published every year, is 2-year-old, and I use that because I would like just to challenge you just to see how many of these things that only 2 years ago were in the peak or near the peak have gone through the disillusion and are essentially already in our life. And I will not go through all this number, which in case that when you have access, you can read, because they contain a lot of interesting information. Some of the number are astonishing, like for instance, that in a few, by 2025, we will be producing in real time 175 zettabyte of data. And the fact that the increase of the use of artificial intelligence sees still an exponential curve. But all these numbers tell us also different stories, is that ICT is no longer a thing where we, as scientists, we think that we have the biggest use in science, in the certain type of high-tech industry, is becoming a thing which pervades the society. And the biggest part of this is outside our field. Although this field uses a lot what we are producing in terms of software, in terms of ideas, in terms of devices. Most of this technology nowadays is used in the society mainly for two things. For selling us something and for financial services, which is another form of selling us something or selling each other something. But there are emerging things which are used more and more in the sense that these not only are tools just to optimize selling procedure and things like that, but they are becoming more and more orienting tools for the customers, for the citizens. And this is less reassuring in a sense, because we have just to see who is behind it, and in a sense guarantee our freedom and our capability just to make choices. as you know, the pandemic have brought in the necessity to have tracing of the people who might be infected. And you know as well that the approach in countries like US or Europe is very much different from other countries where essentially democracy is declined in a more favorable way, let's say so. And on the other hand, even in our free democratic society, Netflix, for instance, saves $1 billion a year in his artificial intelligence-driven recommendation software. But what I find it a bit more disturbing, and that 75% of what users watch on Netflix comes from this recommendation. And the fact that artificial intelligence and this capability of analyze almost real time huge amount of data, the progress that it has been done in face recognition, in natural language processing, is that our data, all the information that we are producing, can be also analyzed just to analyze our sentiments on that. And this is an example which is was used by Amazon, for instance, just to look in the what the people say about what they buy, and it is a very simple example. But artificial intelligence is also blurring the distinction between what is creativity and this. I find it peculiar. Is a painting made totally spontaneously by an artificial intelligence program, which sold for more than $400 in an auction in New York City not long ago. And of course, Edmond de Bellamy is a non-existent name. And last year, in one of these tech fair, Microsoft put in a nice ice parlor. And in front of this ice parlor, there was a screen. And when people were walking by, the screen was asking them, would you like just to have an ice cream? And people would say, yes. And say, can I select the ice cream for you? And while people were essentially looking at this screen with the camera on it, a few images were shown to the people, and the software was analyzing their reaction, their face, and then it was advising, proposing a taste for a flavor for the ice cream, and 68% of the males were saying that essentially this was would have been their choice. Only 38% of female agreed, which is another experimental explanation that women are more complex than men. Now, should we worry? Of course, we should and we should not, in the sense that as every change in our life, it needs us to be governed and not somehow taken for granted or opposed. And the idea is that we have just to get into this debate, not only as scientists, but as citizens. A few years ago, about 10 years ago, as a matter of fact, the European Commission has asked a group of, a very mixed group of people, which included philosophers, ICT specialists, sociologists, lawyers, and a group of very different skills coming from the STEM, coming from humanities, coming from social sciences, just to reflect about what this digital revolution was meaning for us. And they have produced a very nice document, which I encourage you just to download. It's a free download and read and criticize, because I think it's a good starting point. And I'm using some of their conclusion in my talk. Essentially, the reflection of this document is deep, and it says, what does it mean? What is the impact to live in this hyper-connected era? What is our perception of being? What does it mean just to be human in this hyper-connected era? And essentially what they say is that this revolution is increasingly affecting us in our self-conception, who we are, in our interaction, how we socialize, our conception of reality, or our metaphysics, if you like, and our interaction with reality, our agency. Because the ICT revolution is bringing in a big social change of huge political significance. For instance, through this transformation, there is clearly a blurring of distinction between reality and virtuality. I mean, everybody of us has seen perfect fakes of any famous character saying incredible things. Now you can program generative adversary networks just to produce a perfect fake of any politician saying anything. There is a blurring between, which is even deeper, between human, machine, and nature. What is human, what is machine, and nature. We are living in this world in which which has substituted the scarcity of information to the information abundance. And we are less and less to be considered standalone concept or properties or somehow individuals, because this society is essentially bringing us just to be always connected. That's why this manifesto, this book, is called On Life, because in the not too far past, you could distinguish between your being public in the agora, like the Greek were saying, but only 30 years ago, this was much easier than today, or being private in your home, in your. Nowadays, we are living always, never completely online, never completely offline. We are always on life, in a sense. And again, the aim of this work was not just to encourage a philosophy of mistrust, a sort of nowadays Luddism, in which we go and we destroy all the computers in order just to avoid this possible threat. But he points out that we need just to set up a new set of tools, a new conceptual frameworks. In a sense, we have just to redefine a number of parameters and of concepts which are fundamental then just to develop policies around it. And essentially they they underline three points, in which the first one is that we have just to evolve our conception of the self, of ourself, as a relational self. Because in this sense, the blurring of the fact that of the individual inside a hyper-connected society brings a sort of supremacy to the fact that the relational self is the dominating part, which needs just to be looked at with a big attention. You know, modernity has always been based on the fact that the mankind would progress and become asymptotically omniscient and omnipotent. Nowadays, we are in a transition phase in which somehow software machines can do things or reach conclusion faster than we can, and they can act on this conclusion. So essentially, they are putting themselves in the middle between this omniscience and omnipotent by essentially redefining agency as well as knowledge. So, and this is sometimes debated, for instance, when one talks about all the possible difficulties that self driving car can encounter during his normal day. And some of the decision that it has to take, this car has to take, sometimes are essentially pretty much embedded in the ethical issues in that. And there is not yet a solution who is responsible for what in case that a car decides to kill one person just to save 4 persons or similar things. In order just to do that, they say that the second point, which is important, is that we have just to become a digitally literate society, which doesn't mean that we have all become monsters in coding or in knowledge, technical knowledge of computer, but we have just to understand the mechanisms which are behind the ICT and the digital revolution, and on the concept driving them. And the third very important thing I find is the caring of our attentional capabilities. Our attentional capabilities are an asset which has a scarcity. We cannot be attentive more than 24 hours a day, and only for a few days, because before or later we need just to sleep. So our attentional capability is, since it's scarce, is a thing that has just to be preserved, because we should preserve our right not to be given answers to questions we didn't pose, or at least otherwise somebody should reward it in some way. This debate is going on in all aspects of society, and big corporations which are involved in the development of artificial intelligence. Imagine Watson of IBM, or the machine Google, or Microsoft, or the big partners, the big players in this game. They try just to see how just to make this path in such a way that one can go in a safe way, or at least in a thing that can be checked. And of course, all these sort of handbook for the artificial intelligence is also, in their opinion, a starting point, a debate point. But they find five main lines which should be deepened, which is accountability, value alignment, explainability, fairness, and user data rights. And each one of them is self-explanatory in his short statement, but each one of them opens up an enormous and a deep region for debate and for a solution which is a growing and essentially permanent way in which you dig into that. But accountability is that essentially who designs artificial intelligence software should feel responsible in all stages: design, development, decision, processes, and outcomes. The other thing is value alignment. You cannot design an artificial intelligence program software which is good for any place in the world, because there is no the same set of value alignment for not only in different regions, but in different parts of the communities, and who owns at the end the right to insert the basic set of value in which artificial intelligence might predict a behavior or act on a behavior. Explainability is another very important point, and explainability is the thing that saves us from the hidden part of this software that the machine is writing by itself in order just to progress to its so-called reasoning process. And we have just to design it in such a way that we can perceive, detect, and understand this decision process. Fairness is another very important point. There are subtle biases which can be inserted in any software. There are incredible examples of failures of software which was essentially designed based on some biases, and which was producing very disturbing results. And finally, there is the general discussion, which is still not very well addressed. Probably Europe is the one which has, in this moment, the best attempt to protect the owner of the data for the use of the data he generates. But this is another big issue that we have just to face. So, to conclude, I think that the rate of transformation driven by this epochal change is a real revolution that we have just to guide as much as we can. It's also clear, to me at least, in many examples today, that our toolbox, our conceptual toolbox, is not adequate to that. And the problem is that it's not easy just to build a new one, but it is a necessity. The problem is being given that we cannot sit down, build a new toolbox, because of the fast pace in which this revolution is happening. So we have just to build it on the go. And in this book, there is a beautiful image which says, building the raft while swimming. And I think that our responsibility as scientists, we know most of us are very skilled in dealing with computers, with ICT technologies. We have just to go a step further, because we are not only good in doing things with ICT, we are going in, we are the master of the doubt, of the constructive doubt. we can imagine, do good question and imagine possible outcomes. So we have just to help as citizens in this. Thank you very much.